Okay, so hi everyone, I'm Tiancheng from Polyhedra, and today I'm going to present our new proving protocol. And the first demo is about proving full node of Ethereum in zk. So let's get started. Here is our bridge infrastructure, and we are going to prove two things. But the main thing is the block header here. We are going to prove the validity of block header from the sender chain, in the sender chain, and to the receiver chain. So receiver chain will eventually get convinced that the state of the sender chain, so block header state. And to prove a block header, usually people doing is verify signatures. And if you take sender chain as Ethereum, then it will be proving BLS signatures from validators. And this is very hard actually, because you need to prove it in zero-knowledge proof. It's not, if you directly put signatures on the receiver side, the cost will be astronomically high. So, and if you use in zero-knowledge proof, the cost will be like 200K gas, and this reduce the cost by a factor, by orders of magnitude. So to verify Ethereum header, previously we have a way, it's called sync committee. It's a spec of light client in Ethereum. However, there are some serious issues with sync committee. First issue is we found that sync committee will not sign valid blocks. So that can be a flag for a bug in their code. But I think this should be fine for not us. We fixed the bug in our base. And here's two examples. First one is you got only 45% of the sync committee signing. The second one is none of them are signing. Actually, these two pictures are from a valid block. So the big committee, the full node, is actually proved a block, but the sync committee does not sign. Another issue is, if you look at the size of sync committee, it's fairly small. Only 512 validators. They are going to be in charge for the whole day. So they rotate every 27 hours, and their total deposit is only about 16,000 Ethereum. Where you compare it to our bridge volume, the current bridge volume in Ethereum is 20 times larger than this deposit. So they got incentive to attack bridges. And if they do, all of the bridge will collapse. So instead of proving sync committee, here we are going to switch to prove a sync full node. Where in full node, you got more than 20,000 validators per block, and they are going to rotate for every block. So it is at least 20 times larger than the sync committee, but it's actually more than 20 times because they are going to rotate. Different validators are going to join after each block. So as you can see, the number of signatures will also be at 20 times larger than the sync committee. So there is a technical problem here. Previously, we struggled in light client, and now we are going to prove 20 times larger stuff. How do we do it? So we look at the difficulty of this problem. So here, the time limit for our task is 12 seconds. Why? Because Ethereum generates blocks 12 seconds. So you need to catch up it to be able to do a real-time bridging. And if you look at old protocols like Groth 16 or Planck, they are going to take more than 2,000 seconds to prove the full node. So we have a big issue here. So our protocol, I think there's issue with the PPT. So our protocol can prove it within 12 seconds. Actually, it's for about 10 seconds in a single proof. And in this 10-second single proof, we can prove like 2 to 15 different signatures. That's about more than 30,000 signatures. So the protocol looks like the following. We have an algorithm called Virgo. It's in my previous paper, and I think it's the fastest. It's still the fastest zero-knowledge proof protocol. It's 10 times faster, more than 10 times faster than Gross or Planck, anything on the market. And here we are going to combine different machines together to work collaboratively, generate one single unified proof. And combined with the original 10 times faster algorithm, we have like 10 to 100 times faster algorithm, depends on your number of machines. So we can solve that issue, because that issue only like 20 times faster than previous one. And after the Virgo proof is generated, we further use recursion to compress the proof. The final proof will be a tiny proof, like 200 bytes. And the final verification on chain is like 200 kilo gas. So here is a small demo for our prototype. And this prototype will be proving like 30,000 signatures. Let's get started. No, because it's a PDF, we cannot show the video here. Okay, then it concludes my talk. And this is our Twitter link. You can scan it. Thank you so much. Now we are going to a Q&A session. Do you have any questions?
Thank you.
Can you comment on what are the similarities and how different it is from Algorand state proofs and the work they've done on state proofs, if you're familiar with it?
Which state proofs?
Algorand state proofs.
Algorand state proofs.
They're using like light clients, but I think they're requiring 80% of all of the node validators to sign the transactions.
So we use all of the validators in our proof protocol, not only 80% of them. The size of the security deposit is much larger, and our proof system is obviously different than them. We will be super fast. Actually, here in this slide, we show the D-Virgo, but in practice, we only have 1 or 2 machines. That's more than sufficient to finish our task. Yeah, the proof system is so fast, so we don't need a huge number of machines. Yeah. So that's I think that's two differences. The state is still, I think it's the same. We were proving block hashes or receipt root. That's the output will be the same. Yeah, but we operate in a much more efficient way.
Okay, thanks.
Yeah. Any other questions?
Actually, a quick one. What state is the bridge in, like in terms of volume and which of the different chains you're bridging across?
Okay. So here is all the logo of chains we are connected. So Ethereum, BNB chain, Avalanche or Linear, all of the major ones we have already connected. And the volume, I think, since we are collaborating with Layer 0, we will eventually become the default oracle of Layer 0. And currently, we are still running our test bridge because some of the chain is not supported by Layer 0. So from our statistics, we are the second one in the market. And we are larger than all of the rest, except the Layer 0. Layer 0 is the first one. We are larger than all of the rest combined. So we are processing like, I think it's 60,000 transactions per day. Yeah.
Nice. And another quick one. What is the business model for you guys? Like,
Yeah. So currently we are generating revenue from the user transaction. Once they initiate a cross-chain transaction, we will charge a fee. And for the prover, actually, we will eventually open source a prover and let other guys come in. And we can we can charge a proof generation fee in the future.
Makes sense. Cool. Thanks so much.